integrating rational expressions, but this time we first need to make a substitution in order to make it a rational function. So, instead of going all trig sub, let's let k equal the square root of x minus 1. Then what? K squared is x plus 1. Why are we doing this? So that we can rid ourselves of the roots. Root. I solved for x right there by subtracting off the 1. And I find my dx because I don't want to forget that. Yeah, so I have dx is 2k dk. Now I sub everything in. Oh boy! So my numerator becomes k over k squared minus 1, nice, times 2k dk. I say, did I put that 2 out front and then k times k? K squared. For sure. Now what? Well, the numerator and the denominator have the same degree, so I divide, but I don't want to go through the hassles of dividing, so I'm going to add 1 and subtract 1, and you're going to see why in a moment. What do I do? I'm subtracting 1 and adding 1 so that I can split those two fractions. That's what's happening here. I split those two fractions into k squared minus 1 over k squared minus 1 plus 1 over k squared minus 1. Now what? Boom! That's really 1. Let's call it what it is. And then I want to split it up into two integrals. Yeah, those should have been k's. Why? Because now I'm going to do partial fractions. I need to separate that guy on the right-hand side. And that's what I'm doing over here on the side. I factored it. It is k plus 1, k minus 1. They are linear factors, so I do have an a over 1 and a b over the other. So then I add those two fractions. It's over the common denominator. Now I'm gathering like terms. Okay, I gathered my k's and my constants, so what? Since those two fractions are equal, then the coefficients need to be equal since our original fraction didn't have a k term. A plus b is equal to 0, and then minus a plus b is equal to 1. Fun. Little bit of algebra, and b turns out to be a half and a turns out to be a minus 1/2. That was just all over on the side. Now what? I'm going to go and I'm going to throw that in there. That's that 1/2 or minus 1/2. The a went with the k plus 1, so that's why the minus 1/2 went on top of the k plus 1, and the b went with the k minus 1, that's why the half went over the k minus 1. Now, you see that 2 is outside of both of those? Bam! So I distribute that in there, and I'm going to separate those two integrals. Bam, bam. Oh! So the 2 times the 1/2 is a minus 1, and the half times the 2 is a 1. And then I split them up into two integrals. Why? Because naturally, I'm going to do the natural log. So that's 2k minus the natural log of k plus 1 plus the natural log of k minus 1. Then I'm going to combine those logs using my logarithm properties. The one with the minus goes on the bottom. Now all I got to do is back sub. Boom, boom, boom. I stick my k back in. And I add my c. Naturally. And you're done. Box and flower.